Hey there, everyone. I hope you all are doing well. So, can you guys confirm to me, first of all, before we will start our live, that whether I am clearly audible or not? So, I just want a confirmation once that whether my voice is clear or not, and then maybe we can start within few minutes. So, can anyone confirm to me that whether my voice is clear or not? Audible and clear, audible and visible. Perfect, perfect. So let's wait for a few more minutes so that everyone will join. Meanwhile, if you have any sort of questions, anything to ask, you can tap in the chat window. I am looking into that. And if I will be having the experience for that, I will definitely try to share. Otherwise, we will start within few minutes so that everyone will join. It's just 8-1. So the major purpose of today's session, as maybe you can see on the thumbnail itself and the description of this video itself, that the major purpose is we really want to discuss that what is the role of DSA in data science, right? There are so many students who used to ask me on daily basis that whether if I am pursuing maybe some degree in data science or some certification in data science, or whether I am in an industry and I am working as a data scientist, so is that mandatory to have a knowledge of DSA, and if yes, then how much? So today I just want to share you a perspective that I usually say that yes, it is required, but I never explained you that at what point of time this thing is required, and if you don't have the knowledge of DSA, what trouble you might face. It's not like that at every domain in data science, because data science itself is a very vast domain. I hope the audience who are listening here might be aware about the data science also and DSA also. So I'll explain a little bit on the blackboard, but before that, if you will observe that it's not like that in data science in every domain we require a very huge perspective of DSA, but yes, there is a bit of knowledge in every particular domain whatever we have in data science. This DSA is required. So let me try to share my screen once, and then maybe we can start our session. Okay. And I'm looking side by side into the chat window. So that is the only benefit of doing the live sessions on a weekly basis, that if you have any questions in between the chat, and if you want to ask, you can ask me the questions live, and I will take that and I will try to respond on the spot. Okay. So that is the thing which I really like in the live, going live on the YouTube. So let me try to share my screen, and you guys can let me know that whether my screen is visible to everyone or not. Okay. So yes, is my screen is visible to everyone? There must be some black screen coming up. Is it visible? Visible? Perfect. Okay. Now, first of all, let's try to understand what is DSA. What is DSA? By saying DSA, I mean to say it's data structure and algorithms. Okay. Now, you all know that whenever we are talking about data structure, it's a way to structure our data in an efficient way. Now, there are so many different kinds of data structures that we have. For example, we will be having a data structure called as array. We will be having a data structure called as linked list, right? We will be having a data structure called as tree and graph. Let's write in the same category. Then we will be having something called as hashing based data structure. We might have something called as stack and queue, right? So these are the different I would say data structures, And in every data structure, the way to store the data is different. Okay. When I'm saying algorithm, the simple meaning of algorithm is it's simply a, I would say, sequence of steps, right? Here we're supposed to give to a program some sequence of steps, some finite sequence of steps, I should say. So here I am trying to give some finite sequence of steps, right? Why? To, execute a given program, to execute a given program, or you can say to solve a given problem, right? It's a finite sequence of steps. So whenever I'm talking about algorithms, here comes the logical thinking, that how logical you good you are, accordingly you can be able to define that how basically you will be able to solve any code. Now again, in algorithms we have so many different ways. For example, we will be having something called as divide and conquer. And this is built on top of a very amazing concept called as recursion. And there is something which we have is backtracking, right? Apart from this, we will be having a very amazing concept of dynamic programming in algorithms. Again, you should know that why at every point of time uh, this module is required. At any point of time, at what point of time we should go for DP. It's not like that for every particular problem you can go for DP. Similarly, you will be having something called as greedy algorithms. And one of the amazing application of greedy algorithm is finding of shortest path, which is famous by the name of Dijkstra's algorithm, right? Dijkstra's algorithm. Or you will find out a job sequencing kind of a problem. In order to basically sequence the job within a given deadline, how should I sequence them? Again, it's a concept of greedy algorithms. So the simple meaning which I want to say here is that we do have a different set of data structures, and we do have a different set of algorithms, right? And now the question which students ask to me, that I am a data scientist, right? I might be working with a ML problem, I might be working with a DL problem, or I might be working with a NLP problem or a CV problem. Now, where do I use these kind of things which I am studying in DSA? And then why should I study that? If I am not using in industry, then what's the need of study these concepts? See, whenever I am talking about data science domain, in data science domain, if you will observe, we will be having the problems with respect to machine learning, right? I hope you all agree with me. We do have a problems of machine learning, right? We do have a problems of deep learning, deep learning, and in this category itself I am writing as computer vision. Okay, computer vision. We do have the problems based on NLP, which I called as natural language processing, which basically deals with the textual data, natural language processing, right? Or maybe you are dealing with some other different kinds of domains that we have. But the question here is that why we are, how basically we are using this DSA in this domains. Now, whenever I'm talking about that you are dealing with deep learning or computer vision kind of a problem, you are mainly dealing with the images. I hope you all agree with me that in maximum scenarios, we are dealing with the images based data set in the computer vision. I hope everyone agrees with me on this note. Please create a video on list of companies offering internship. Yeah, this I have already noted it down. Next week, a video will be released for that. Okay. Saurav is saying why structures are needed. What kind of structures you're talking about here? Is that data structures you're talking about? If you are saying with respect to data structures, so the data structures are required to store the data, whatever data we have, efficiently. And it depends that what kind of circumstances that we have. For example, sometimes, suppose if interviewer is saying to you, or a manager is saying to you, that I will be having a number of records, and in those records, what I really want is, I want the searching operation to be very frequent. So you should know that what particular data structure you should go for. In that case, you can go for arrays. But if they are saying that insertion and deletions are the one which are highly frequently used, then maybe you can go for linked list. If you are saying that there is a problem of networking, you want to see a networking kind of a problem, for example, social media, LinkedIn, how networking is happening with the help of a graph based data structure. So the why data structures are required. Data structures are required to store the data that we have in an efficient manner. What is the meaning of efficient manner? The simple meaning is that it depends on the kind of a circumstances, the problem statement which is given to you. Accordingly, via the knowledge of each and every data structure that you have, you need to decide that which particular data structure is the optimal one in that situation, right? So that if I want to grab any data, I will be able to get very fastly. If I want to search any data, I can be able to search that. If I want to insert any new data, I can be able to insert that. If suppose I want to do a key value pair kind of a thing, then again hashing came into picture. If I want to get a LIFO kind of a architecture, for example, undo operation that we have in our system, where the last value which we deleted will come first. So that kind of architecture will come in stack. If I want to remove the browsing history of last month, then queue based data structure will come into picture. Why? Because I want to do a FIFO kind of architecture. So depending upon what kind of problem is given to you, a separate data structures we have. Right? Now, the question is, when you are dealing with the images, I hope you all know that whenever we're talking about images, we are actually, whenever we feed image into our model, these images will be converted into, can anyone tell me, pixels, right? Suppose an image is of RGB, red, green and blue. So there will be three channels, right? RGB. So in that case, you should have knowledge of what is 3D array kind of a thing. So whenever we are talking about arrays, specifically a multidimensional arrays, right? Multidimensional arrays. If suppose someone is not aware about what is an array, what is a matrix, what is the concept of 2D array, 3D array, rows, columns, so how will he able to understand what that matrix is denoting inside that, and how we will be able to access those values inside the list that we have? Because for a person it seems like an image is there, but actually that image is not there. What is a pixel inside that image, that will be there, right? Now, if suppose in a machine learning problem, you mainly deal with the numeric data, right? You mainly deal with the numeric data. And suppose that numeric data contains a lot of records. It contains a huge number of records. And what you really want is, you want to sort your data, that CSV file that you have, you want to sort that on the basis of maybe employee ID, or you can say EID, right? Now, if you want to sort it maybe on the increasing fashion, again, how the sorting algorithm will work? How the sorting algorithm will work? You need to know about something called as merge sort, or you need to know something called as quick sort, which are one of the most efficient sorting algorithm and will solve the problem of sorting in big O of n log n. Now, one of the amazing thing which only those people can do who have the clear cut idea behind DSA, the concept of time and space complexity. The concept of time and space complexity. Now, many people who are not aware about DSA, data structures and algorithms, don't even know what is time complexity, what is space complexity. Whenever you are writing any code, right? Whenever you are writing any code, how much time it will take to execute that code is something that we are saying as a time complexity. And how much extra space you are taking to execute that code is something that we're calling as a space complexity. Now, what we really want whenever we're writing any code with respect to data science per se, or any code whenever you're writing, whenever we are saying that you need to write an optimized code for a given problem, what is the meaning of that? The simple meaning is that the code should be in such a way that it should have a very low, very low time and the space complexity. Means the time required to execute that code will be less, and even you should not use any extra space to execute that. Now, how will we able to determine that this particular code is having a high time complexity and that particular code is having a low time complexity? It basically depends on majorly how many number of loops you are using. And sometimes I usually see in a code there is a lot many, there is not even a need of using those loops, but people are still using that because they don't even know that these loops are the very costly operations, and it will take too much time to execute your code if you're increasing the number of loops. Similarly, you should know that at what point of time you should go for recursive codes, right? And at what point of time you should not go for recursive codes, because recursive codes also require extra space to store the function calls in the stack, right? Correct or not? Now, apart from this, even suppose I want to search any data inside the given records. Again, that's where binary search will come into picture. Now, those who don't know how binary search will work, they will definitely face the trouble. Right? Now, whenever we are talking about, algorithms in machine learning, we usually have a k nearest neighbor, right? How many of you know this algorithm? Or we will be having something called as an unsupervised, called as k-means clustering. Usually what we do, we used to have nowadays scikit-learn, right? We usually have nowadays dot sort function to sort, which internally we'll call the quick sort or the merge sort depending upon the situation. And then we will feel like that why there is a need even to understand the mathematical intuition of any algorithm, because anyhow we can get the result, right? That is what matters. No, this is where you're facing the trouble, not in maybe today but in future, because these are the abstracted things that you look into in order to get the output. But as a beginner, if you're starting your journey with respect to any domain, you should know the internals of those stuffs as well. Why? Because if in future you are expecting to do some research or going for some very good companies where they are working internally on these things, then at that point of time you will face a trouble. You never go there, you never will be able to reach there, because you don't even know that how internally things are happening. You just know the abstraction part of that. And even when you go for an interview, again, that's another motivation that you should have. Whenever you are going for any interview with respect to data scientist, at least in big companies, the very first round is of DSA, where they will try to judge you that okay, whether you will be having a good logical thinking or not. Now, coming back to this k-means clustering or k nearest neighbor, what I really want to talk about Yes, you can directly extract the scikit-learn packages, and you will be able to grab these algorithms directly. I'm not saying that it's bad. What I'm saying is you should know the internals of that as well. How you will get to know? Via the documentation. Every algorithm has its own documentation. Now this question was asked by me in Google company. What they told me that, can you implement the k-means clustering algorithm, or what kind of data structure you will use in order to get the you know minimum distance at each and every time. Even whenever we are talking about k nearest neighbor, we usually want a minimum distance. According to the distance basis, we will be able to see how many data points are nearest to each other. I hope everyone knows what's the mathematical idea behind these two algorithms. The difference is, above one is a supervised one, below one is a unsupervised one. But in both of the cases, I really need to find out the minimum distances. And that we usually find via the Euclidean distance. I hope you remember these algorithms. Everyone knows about k nearest neighbor and k means clustering algorithm, those whosoever watching this live. Now, if suppose maybe you will be able to find out a Euclidean distance, talking about any of the algorithm. Suppose let's talk about k-means. Now, suppose you will be able to get a, on the basis of the distances you are trying to cluster the data points that you have. Suppose you have applied Euclidean distance. Okay, I have created a separate function for that, and you all know that how basically Euclidean distance will be formed. We have given two coordinates, suppose x1 y1 for the cluster number 1 and x2 y2 for the cluster number 2. So we can create a function, that's fine. We can say it will be x2 minus x1 whole square plus y2 minus y1 whole square. The question is that we want at each and every time minimum distance. How will we able to get that? Now, if someone doesn't know, or if someone doesn't even have a look onto how we are getting internally, here though we are calling on the package, but internally how we are getting the minimum distance, then it's a trouble for you, right? How optimization will happen on top of this k-means clustering algorithm to get the minimum distances at each and every time? Any data structure that you can think of which will be able to give me a minimum distances at each and every time? Anyone? Let's see what are the answers you are getting. Any of the algorithm or data structure that you can think of which will give me a minimum value, minimum distance. So I have created a separate function which is responsible to give me a distance of between two data points. That's fine. Now what I want is, on the basis of those distance values that I will be able to get, I want the minimum at each and every time. How will I able to get that? Which data structure should I use to do that? Any idea? Anyone? Anyone can think of? That's where the concept of heap based data structure will come into picture, where we will be having something called as min heap. I'm not sure how many of you are aware about that data structure, but min heap, if I will try to create a min heap on the basis of the distances that I have, so at each and every time, whenever I will delete the data from the min heap, which is just popping it up from the topmost, getting the minimum distance, which is just a constant time operation, I will be able to get that. To get a minimum value from a min heap is just a constant time operation. And that's the beauty of min heap. Whenever there is a need to get a maximum element each and every time, there is a separate data structure that we have called as max heap, which will be able to give me a maximum value at each and every time, you know, within a constant time complexity. Now, these things, these stuffs, if you will observe, only those people will be able to understand who already knew about this DSA. Even whenever we are talking about something called as GPS, nowadays we're using a lot of map, right? In order to go from one place to another place, we will use definitely GPS. I think everyone is using GPS nowadays in whatsoever location they are. Whenever we are tapping that I want to move from location number A to location number B, right? GPS usually talk about the minimum distance, or I would say it will give me a shortest path, which will help me to reach from A to B, from source to destination. So, how basically this is happening? Again, in this case, we are usually using a concept of algorithms. Greedy algorithm is coming into picture by the name of Dijkstra's algorithm. On top of that, obviously, on top of that, obviously, there is a lot of machine learning based algorithms which are applied in order to give us the, uh, you know, tell us whenever we are booking a ride that whichever person is the nearest one, we will be able to get that ride, right? But yes, the very first thing is the DSA, which is coming into picture, which is basically telling me that okay, whenever you will try to move to point A to point B, this is the path which you should follow, right? Any doubt until so far? Anyone? Next important thing, apart from this, I hope you must have heard of ensemble techniques in machine learning. A very famous algorithm is random forest, which is basically used for both classification and regression task in machine learning. It is useful for both classification and regression task. Even we will be having again decision trees. I think everyone knows that random forest is built on top of this decision trees itself. Again, this is also useful for both classification and the regression task. Now, whenever I am saying trees, random forest, decision tree, all these are the trees, right? So obviously, in order to create a tree, you should have a basic idea what is tree data structure. On top of that, the concept of something called as Gini, that we have Gini index or entropy will come into picture. But if someone doesn't even know what is a root node, what is the internal nodes that we have, what is the leaf node that we have, then how will you able to get a proper idea about a decision tree or a random forest? Even not only in this case, but also whenever we are talking about the optimization of any algorithm. Suppose today some researcher have designed k nearest neighbor. Now k nearest neighbor is taking a too much time. It's having too much time complexity, and they want to optimize the code. And that's where researchers come up with something called as KD tree in order to get the fast results. Now again, this KD tree is built on top of something called as binary tree. Now, if there is someone who is not even aware about what is the binary tree, how the optimization will happen. So, in a nutshell, what I really want to talk about here is that it's not like that you are using a lot in industry with respect to the DSA. But whenever you are trying to do the optimization of any code, whenever there is a need of optimization of any code in data science, of any code in data science. Optimization means, I'm again saying its simple meaning is that if you want to reduce any model's time complexity, at that point of time, you have to think that what is the optimal data structure I should use? What is the optimal algorithm should I use in order to get a efficient result? And that's where again DSA will come into picture. Without having this knowledge of DSA, you will not able to answer that. Apart from this, if you really want to crack any good product based companies, right? Even for the data science round, they will definitely ask you in the very first two rounds, the first round which is of giving you a lead code based questions and telling you that you should pass all the test cases. So 2 or 3 coding questions will be given to you where you have to pass the test cases on those questions. And second thing, again you will be having a technical round where again the questions of DSA will be asked. And after this only you will be able to get a chance to go for the third round, and that's where they will talk about your data science projects. That's the two biggest motivation for you all to study DSA whenever you are studying data science. And that's the real objective which I really want to deliver here in this particular session. Now, if you have any doubt with respect to anything, whatever I have talked about from last 30 minutes, you can ask from me. Otherwise, we can wrap up the today's session. And even the next week, if you have something in your head, you want me to deliver that kind of a session, you can give your suggestions in the chat window or you can write in the comment section. I will for sure look into that. And if possible for me, I'll try to organize one more session next Sunday with respect to some different topic. Right? Is there any issue with respect to whatever things I have talked about? So we have seen that where at what scenarios this kind of DSA is playing a very important role even in data science. Are lead code YouTube questions enough for DSA? See, there is not a good number which I can say that okay, this much if you will do, this much is enough. What I usually say to everyone is that whenever you are doing lead code based questions, try to do quality wise by saying that, see, we can't solve multiple of problems because apart from DSA, we have other stuffs to do, right? We have to do the projects as well. We have to build the stuffs as well. So what I usually say is that even though you will do very small, very lesser questions on the lead code, the objective is that you will be able to understand the question very thoroughly. You should know that how that question is working internally. So whatever be the important topics that we have, for example, binary search is one of the most important topic in DSA. You can take that concept pretty well and then try to solve few questions on lead code with respect to binary search and try to see that how basically this binary search is working internally. Similarly, for other questions also, there are very few topics that we have in DSA which plays a very, very important role, right? So if you will be able to crack those topics itself, then you will be able to crack any company. The problem is that people don't know that what stuffs to study and what stuffs not to study. It's obvious that the more question you will solve, you will be able to get a better idea about the concepts. But yes, after some point of time you have to stop and you have to search for the companies also. So you have to be constrained within a deadline that you have settled for yourself. There is not specific number. I have seen a person who have done 2000 plus questions on lead code but still will not able to crack any good company. I have seen another person who is just done 200 questions but still able to crack the companies. Interviewers are not looking for the exact solution. They are looking for what kind of approach you are applying in order to look for the problem that you have. So they are looking for the approach, specifically in the technical rounds I am saying. They are looking for the approach. If you will be able to think like that, they will be definitely able to take you. I hope this answers your question. Neat code, it's neat code or lead code YouTube questions you are referring about, so what I'm saying is focus on the quality. Okay, even though you will solve maybe very 20-30 problems of DSA, the problem is people usually don't focus on the quality. So try to be focused, try to spend as much time as you can on your learning, and do it. I think a few days back only I have uploaded one video that how basically we should learn DSA. So whenever you are studying any topic with respect to that, go with respect to that questions and try to go deep into that. Okay. I am comfortable with linked list, arrays, and hash map. Do I need to add extra for data science? You should be comfortable with trees and graphs. And apart from that, you should have a good idea about, heap based data structure as well. So trees and graphs is priority one. Apart from the things that you have mentioned, you should have a good idea about trees and graphs because it is widely used even in data science, right? Just now I gave the example about the decision trees and random forest algorithms. Whatever tree algorithms that we have in data science, all are using this tree based data structure. So you should have a knowledge of that as well. Right? Any other question anyone is having? So I will try to share these notes as well in the comment section. And please hit like button with respect to this video. Try to share this video with as many people as you can. And can you tell me what kind of DSA is required in linear and logistic regression? Okay. So whenever we are talking about linear regression, I have uploaded this video also on both of these stuffs, linear and logistic regression. So in linear regression, we are trying to generalize a line, right? Where the line equation is y is equals to mx plus c. Now, obviously, when I am using the optimizers to optimize that value of m and c, at each and every time, I am doing the iterations, right? I am doing the iterations so that my error will be minimum. I hope you are understanding my terms which I am saying. If not, please go to that video. You will be able to understand that what terms I am hearing referring to. Now, when you're using the iterations, same thing is repeating again and again, but with a lesser error. At one point of time, it will stop when you will be having a lower m and lower c, right? The error will be minimum. In other words, so how basically you are executing that thing? How basically you are executing that thing? Obviously, you need to apply one for loop and you need to write inside that when the error, which is nothing but the difference between the actual and the predicted value, is zero or approximately equal to zero, at that point of time you will break out of this loop. So this is something, we have theoretically understood it that how basically it is working, but how the coding will happen? In that case, obviously you have to apply that programming constraints. You have to apply that optimization part, gradient descent in a way. How the implementation of that will be done without DSA knowledge? And then talking about the time and space complexity with respect to the writing the code. How much time complexity is required to execute that code? Well, it depends on how many number of iterations it is doing. So if the number of iterations are n, so it will be big O of n. Are we using any extra space? No. So the space complexity will be constant. Right? I hope it answers your question. Recommend any good resource for DSA? So for DSA, there is one book by the name of Introduction to Algorithms by Corman. It is also, ebook is available on my GitHub repo. I will try to associate that link also on my comment section. It's there in my GitHub repository. If you want to see the ebook, you can refer that. It's the standard book. And I usually say that refer any standard book rather than referring any XYZ books, because there might be the mistakes in those books. But usually in standard books, the mistakes chances are very, very low. Okay. And if you want to learn from YouTube, you can refer the MIT lectures, which are freely available for DSA, right? You can go there, check it out. The only thing is that nowadays we really want short kind of videos. But when you will see the actual content in any of the YouTube channel, it should be very lengthy. It kind of 1 hour, 1.5 hours. Even in MIT lectures, it's a very big lectures of DSA. But if you will be able to ingrain that, you will be having an actual knowledge of DSA, right? Uh, DSA is something which is independent of any programming language. So, whenever you are referring any resource with respect to DSA, don't focus on what programming language it is having. Specifically, the reference book which I am giving, the Corman book, it's not associated with any programming language. It just talks about the logic. It just talks about what is the time and the space complexity. Just talk about the data structures that I have written. The conceptual things are there, the logical things are there, independent of any programming language. So I'm not saying the book with respect to the programming languages here. Okay. So I hope it answers your question. And with this, let's end this live. I will see you all very soon. And you can also write it down what topic you want me to cover up in the next particular live. And I will definitely try to do that, right? So with this, bye bye, good night, and happy learning to all.